Alright, so now we want to know how to find eigenvectors of a matrix. So let me touch it in a very general way, and in a very practical way we can use them in our differential equation lesson. So even if you know this, please be with me until the end of the video because I want to share some tips. Okay. Alright. Now let's say we have a system of we have a matrix and we know the eigenvalues already. Now finding eigenvectors is, now you want to solve this equation for k. K is a vector. So you do that for each eigenvalue. So first take first eigenvalue, lambda is equal to 3. Okay. Now the first step would be find a minus lambda I. Okay. Later we will deal with this equation, but for now, right now, find a minus lambda I. So a minus lambda I here is a minus 3 times I, right? Because lambda is 3 in this case. So 2, negative 4, negative 1, minus 3 times I is, so 3 times identity is 1, 0, 0, 1. So 3 times identities, you can delete this 3 and instead of 1, you can put 3 there, right? Okay. Identity matrix is the matrix where you have 1 along the diagonal, everywhere else it's 0. But when you multiply it by 3, the diagonal become 3, right? So now if you subtract element by element, 2 minus 3 is negative 1, negative 4 minus 0 is negative 4, negative 1 minus 0 is negative 1, negative 1 minus 3 is negative 4. So you get this a minus lambda I. So that's what you need to do first. Now write a minus lambda I times k is equal to 0 equation. Here I'm going to share some secrets. So be with me. Negative 1, negative 4. So capital K. K is a vector, eigenvector. How many rows it should have? It should have 2 rows. 2 unknowns, K1 and K2. So if we know K1 and K2, simple K1, little K1 and little K2, we can find the eigenvector, right? Okay, because this is a 2 by 2 matrix, your eigenvector is 2 rows and 1 column, right? So you want to know this K2 and K1. Okay. So here's the thing. Now, when you have 2 by 2 system, what I would want you to do is multiply this matrix by this vector and get 2 equations. But in a 3 by 3 matrix, I highly recommend you to do the Gaussian elimination. We'll come to that later. Okay. But here now you do the multiplication. But if you want 2 by 2 matrix, you can do the Gaussian elimination. But here let me show you something. Let's multiply. First row multiply this column. Negative k1 minus 4k2 is equal to 0. Here using this row and the column, negative k1 minus 4k2 is equal to 0. So you get 2 equations. Let's label them. Here's an important thing. Really, when you're finding eigenvectors in a 2 by 2 case, even in the 3 by 3 case, even though you can see there are 2 equations here, this is only a 1 equation. Do you see that? You see that, right? Second equation is same as first equation. So we really don't have a second equation. Really, we cannot solve for K1 and K2 because we don't have enough equations. We have 2 unknowns, K1 and K2, but we don't have 2 equations. Other equation is the same as first equation. This is exactly the case every time. Okay. So don't expect to get fully solved. Oh, this is my K1. This is my K2. No, you're not going to get that. Okay. Instead, you have to decide what am I going to choose for K1 and K2. Let me explain this. So let's make a relationship between K1 and K2. Even in 3 by 3 case, you get little K1, little K2, little K3, right? Because it's a 3 by 3 case. You have to make a relationship among K1 and K2 and K3, okay? You cannot solve for K1 and K2 just nicely and get, oh, K1 is this and K2 is this. Okay. So here the relationship is, let's take the negative 4K2 to the other side. So K1 is 4K2. If you divide by negative, K1 is actually negative 4K2, right? Now, here's the case. Now, you get to choose. Yes, you get to choose your K1 and K2. Choose K2 smartly and then you get K1. So choose any number you like for K2 but not 0. Okay. You have to make sure when you're choosing these K1 and K2s, that you don't get 0, 0 as eigenvectors, because 0, 0 is never an eigenvector. The 0 vector is never an eigenvector. So make sure that doesn't happen. Tell me a smarter choice for K2. You can choose any number. 1, 2, 3, 4, 5, 6, -1, -2, -3, any one. But who's the easiest? 1, right? Let's choose K2 to be 1. Then what is K1? -4. This is your eigenvector corresponding to the eigenvalue 3. Do you get this? This is exactly what happens every time. You cannot solve for K1 and K2. You have to choose K2. Then when you choose one variable K2, you automatically get the other variable depending on what you choose. Here, you can choose -1 for K2 also. Okay, let's say you choose -1 for K2. That's also correct. Okay, I'm not going to mark down you wrong. So K2 is -1, then K1 is 4. But these two are same thing, right? You can multiply what I have inside the circle by -1. You can get the vector that you did, right? So you will get linearly dependent vectors. So you can choose anything. It will be the same copy of what I choose, what I would choose. Okay, so don't be afraid to choose any number. But here's the tip. What would you choose? Choose the simplest number. Okay, don't choose 0 so that you get 0, 0, but choose the simplest number. Usually 1 or -1. Those are the common choices. So let me just finish by finding the other eigenvector, because you have 2 eigenvalues, so you have to get the other eigenvector. So lambda 2 is equal to -2. So we find a minus lambda I. Now be careful here. This is a minus lambda is -2. A minus -2y. So here this is actually a plus 2y. Do you see that? Yeah. So what is a? 2, -4, -1, -1 plus 2 times I is actually 2, 0, 0, 2. So here it's plus. Okay. So if you add, what I get is 2 plus 2 is 4. -4 plus 0 is -4. -1 here. -1 plus 2 is 1. So this is a minus lambda I, which was a plus 2y. Now again what you do is, so you write the equation for -4, -1, 1. You solve for little k1 and little k2, right? You can still use the little k1, little k2 notation. Don't worry, you're going to get numbers for them. So it's okay. So now we multiply these equations. 4k1 minus 4k2 is equal to 0. -k1 plus k2 is equal to 0. Now do you get the same equation? You should. Check. Pause it and check. You can multiply the second equation by -4. So -k1 times -4 is 4k1. -4 times k2 is -4k2, right? So you can scratch out one equation. Usually scratch out the difficult looking equation. Keep the simple looking equation, which is this. So k1 is equal to k2, right? Even if you use the previous equation, you divide by 4, eventually you get k1 is equal to k2. Now what is the smarter choice for k2? Choose k2, then you get k1. Of course 1, right? 1, 1. When k2 is 1, k1 is 1. So this is the eigenvector corresponding to the eigenvalue -2. So let's write down neatly. So eigenvalue 3, the eigenvector was -4, 1. Eigenvalue -2, the eigenvector is 1, 1. Okay, so that is how you find eigenvectors. This is consistent with 3 by 3 also, but I do Gaussian elimination there. So please be patient enough to rewatch my watch my Gaussian elimination review video and watch all the videos that I have done. This is super crucial. Without this, you cannot further move on at all. Okay, so it's very crucial. So understand this scenario. You cannot solve for k1 and k2. You rather do some smart choices. Okay, all right. So practice enough problems. Practice makes you perfect. You cannot survive this course, rest of the course at all, if you do not learn how to find eigenvectors and eigenvalues, even for 3 by 3 matrix. Okay, all right. Thank you very much. Then see you in the next videos.